7.5, number 8. It asks for the sine of the arcsine of square root of 3 over 2 minus the arccosine of 0. So I've drawn over here, let me get my pen, I've drawn over here what the domains are. This first part is alpha, the second part is beta. Now if we can find exact angles that are on the unit circle, we don't have to use our identity, sine alpha minus sine beta. But if we can't, then we'll have to use it. So that's why I'm writing them down as alpha and beta. So remember, sine goes from negative pi over 2 to pi over 2 inclusive. So this one says the sine is positive, square root of 3 over 2, so it's in the first quadrant. Remember, sine is negative in the fourth quadrant and positive in the first quadrant. So we know we're in the first quadrant for the first one. And if you look at your unit circle, the sine of what equals square root of 3 over 2? Because that's what this means. You can solve this equation. Some angle, we'll call it alpha, equals the arcsine. You can write arcsine or sine minus 1 of square root of 3 over 2. So that means the sine of the angle equals square root of 3 over 2. So that's what it means. You can write it out, or you can just look at it up here and say, all right, I want some angle that has a sine of square root of 3 over 2. Because of the domain of arcsine, we know that's in the first quadrant, and that is, I had it, but now I don't remember, so let's look at the unit circle. Square root of 3 over 2 is pi over 3. So that's pi over 3. So the first angle, alpha, is pi over 3. Minus. Now we need an angle. Here's the domain of arccosine, and you know that pi over 2 in that domain, cosine is 0. So this is going to be arccosine is equal to 0. The angle is pi over 2. And again, if you want to, you can solve the equation. Pi over, or some angle, we'll call it beta, equals arccosine. I'll write it like this time, of 0. And so that means that the cosine of beta equals 0. And it's got to be within the domain of arccosine. So you know that's pi over 2. Now again, we can use the long formula, or, and let me get some extra room here so I can write it, or maybe these angles will add up to something that's right on the unit circle. So let's check it out. Pi over 3 minus pi over 2. This is not some weird symbol. It's supposed to be pi. Pi over 3 minus pi over 2. To add them or subtract them, we need a common denominator. We'll use 6. 3 goes into 6 twice. 2 times pi is 2 pi. Minus 2 goes into 6 3 times. 3 times pi is 3 pi. 2 pi minus 3 pi is negative pi over 6. So that's what this is. This is really the sine of negative pi over 6. And what is the sine, what is the sine of negative pi over 6? It's negative 1/2. And I'll prove it to you on the unit circle. Here's pi over 6, so here's negative pi over 6. It's negative 1/2. So the answer to this is sine of arcsine of square root of 3 over 2 minus arccosine of 0 equals negative 1/2. That's the answer. And again, you could have worked it with those formulas. Sine of alpha minus beta. You could have worked sine alpha, cosine beta, minus cosine alpha, sine beta. But since these two angles that we found, since this angle, some angle has an arcsine of square root of 3 over 2, and that angle is pi over 3 according to the unit circle. And then some angle has a cosine of 0 here in the domain of arccosine. With arcsine, it's in that domain, and that's pi over 2. So since those angles added up to an angle that's right there on the unit circle, we don't have to go through this formula. Don't have to worry about it. All we have to do is add those angles up and then find the sine of whatever they add to, or in this case subtract to. Sine of negative pi over 6 equals negative 1/2. So there's your answer for 7, 5, number 8. Let me get to this.